Alright, so we have started a new live stream, and this one is going to be based on checking the power output of the Whoop going through different types of connectors. Now, I've been saying that the power Whoop with the JST 2.0 provides more power than the smaller JST. Well, we're going to actually get some empirical data, and we have a way of measuring that. So the way I have this set up, I'll quickly kind of explain the test, and as long as it's consistent, I think it'll give us good results to kind of make opinions, but we'll just roll through it. So this is a power meter. It measures peak current, peak voltage, and also instantaneous current voltage, all that good stuff, so we can monitor what's happening with the power as it goes through the Whoop. It is powered independently of the battery that we plug in. That way we're not pulling extra power to run the sensor. That's all going to be not affecting the battery. Also, we have two connectors. One is the power Whoop, one is the JST. They both go to XT60 connectors, and what I basically do is as soon as the battery plugs in, it's basically a normal connection like it would go to the Whoop. Then it goes into a really big gauge wire with big connectors, so that there is no, there's minimal resistance added to what we're currently using on the connectors. So ideally, the difference is it doesn't matter what's happening with the equipment. The difference is on this end of the connectors, where we should be limiting or adding resistance to the flow. Okay, so that being said, I have two batteries that are charged at max, which is I think 4.37 high voltage current. And these are right off the charger. And then I've got another pair of the same batteries that are, I think they're at like 4.11 volts. And that's to kind of give us an idea of, as the pack's getting lower, what is the max current draw? Because I have a hunch that as these connectors it'll make more and more of a difference whenever we're getting lower in the current and we have less voltage. And there should be, hopefully we'll see all this on the stats, but I think it'll make a bigger difference also when your voltage in your battery is getting lower as far as what connector you have. Okay, so I have USB going to the Whoop, and that will be controlling, because I played around a little bit with having my Taranis, but the motors weren't staying evenly on. So I'm basically plugging it into Betaflight, and I'm going over to the motor configuration tab and just controlling motor output that way. I know all the motors are equally being powered on. All right, so let's do the first test. We'll start off with the smaller connector, and we will do the let's do the smaller connector with the 4.11 volt battery. And I'm going to plug that in, and I'll go over to the motors tab, and then I'll punch it, and then we'll come back and look at, and it'll tell us the peak current output for that. So all right, so we got 4.11 volts. I'll plug in USB, and then that's the current output is at top, and then that's the max current output. So I'm gonna go hit that. All right, here we go. All right, so it looks like we peaked out at, let's see here, 5.45 amps. Okay. Now let's go ahead and switch the connector to the power Whoop, and let's see if it makes any difference. And so this will keep the 4.45. So if that number, that 5.45, goes up at all, that means that we hit a new peak. 4.11 volts, so the same voltage. All right, let's hit this. Here we go. Yeah, that's a big difference. So our peak current output with that one is 6.57 amps. So that's a pretty significant difference. And I think that's probably what I was thinking earlier, as far as at a lower voltage, when your pack voltage is getting, you know, below or close to the end, having a better connector will allow you to have more punch all the way to the end of your pack versus the smaller connector. I hope that makes sense. I might not be verbalizing that in a way. So okay, that was, again, a partially discharged pack comparison. Now let's jump to, and we'll reset this. So now we've got, let's see here, come on. All right, so we reset this, so now it has no peak recorded. We'll take this connector back out. All right, we'll put the smaller JST 1.25 plug back in. And again, this is a fully charged high voltage pack. Let's take a look at what that does. 4.37 volts. All right, let's punch it. All right, so we peaked out at 6.42 amps. That's pretty good. Definitely a lot more than the 1 amp that this little plug is rated for, but it's doing pretty good. I am surprised that it's letting that much through. All right, so now let's swap over to the power whoop connector. .42 amps was the max on that one. 6.42. All right, same battery voltage. Let's give it a punch. Let's see here. 6.9. Okay, yeah, so it is better, but it is not as significant of a difference as when you're at a lower voltage. So I guess that kind of wraps up this whole test. There's probably going to be a bunch of people saying, oh, you didn't do this or that. But I think as long as I keep everything the same and it's a comparative test where I have similar batteries, all these batteries have had the exact same amount of charges, cycles, and been charged the same amount of times. So there should be very little difference within the batteries themselves. And yeah, I guess let me know what you think about this type of test. Is there something that I'm doing wrong? I mean, I'm all about this type of empirical data. I love doing this kind of stuff. So if you have any suggestions, I'd appreciate any advice. But it seems like, yeah, if you want the maximum amount of your batteries possible, and maybe getting not necessarily longer flight times, but keeping that punch, that power throughout the battery, even when it's getting lower. The power whoop connector, the JST 2.0, is definitely the way to go, and don't use these tiny little guys. Okay, so let's take a quick look at comments. Let's see if there's anything going on here. Alec Ryan asked, did you not swap out the camera for the one that you separated into the low profile separate? Okay, no, Alec, I have the mullet mod still here. I haven't swapped it over. I'm slowly kind of cranking through all this stuff, so that will eventually come through. Let's see, Alec Ryan also agrees that there's a huge difference. Robert Macaroni FPV says, is that the Betaflight FPV flight controller? I have that one. Yes, this is the Betaflight FPV or Beta FPV flight controller. It is the FRSky long range, but it does not have OSD, and you can see there's like the little antenna guy right there. Also, yes, 3-blade props. Robert asked another question, where did I get these? These are the 3-bladed props that came with the Beta FPV frame. So Beta FPV sells their own bladed 3-bladed props, but I got the frame kit that came with props. So that's just what I'm running. I'm actually really happy. I've heard people say that the 4-bladed props like these work really well, but I've been flying around and I'm liking these 3-bladed. I haven't really had a reason to swap, but I'll definitely be playing around with that some more. All right, let's see here. The Undercover Spy Sipco says, nothing to do with what you're making, but have you ever used a 3D pin? No, I have not. Well, okay, I have used a 3D pin. It was like when they first came out, and it was pretty terrible. I have seen some people do some awesome stuff with 3D pins. Now, I think if you get a good quality one, then you can do some cool stuff. But I had a bad experience with one. I haven't touched one since. That was like a couple years ago. We got another couple questions. Okay, yeah, well, I think we're going to call it wraps for now. But yeah, that's this test, and I think I'll probably be, as I get more batteries and do more stuff, I can keep, this type of test, and we can rerun batteries and see what type of, what's the word I'm looking for? discharge. Thank you. We can see what type of discharge, if there's any difference in the better discharge batteries, higher C rating batteries. With this type of rig, we can definitely get some empirical data on that versus just, you know, how it feels in the sticks. All right, now I'm going to fly this around with a new connector, and I'll post a video of, I think it'll probably be quite a bit faster. So if I'll post a FPV video just flying around the house so y'all can kind of get an idea of the performance increase just swapping over the connector. All right, guys, thanks for tuning in, and I will see you next time.